All right, welcome everyone. Please note that this session will be recorded for our informational, educational, and marketing purposes. Our event will begin shortly. Well, good evening from Singapore and good morning and afternoon if you are joining from the other sides of the globe. On behalf of Nanyang Business School NBS, United Nations Supported Principles for Responsible Investment, PRI, and the European Corporate Governance Institute, ECGI, a very warm welcome to our second lecture of the year for the NBS-PRI-ECGI Public Lecture Series on Sustainable Business. My name is Yuxia Zou. I'm Assistant Professor here at NBS and your host for today's session representing our lecture organizing committee. So our lecture series is a global initiative started last year, aiming to facilitate knowledge exchanges among academics, practitioners, and policymakers in the field of sustainable business. We have 8 lectures per year. Each lecture features a leading scholar and an industry expert to help connect academic insights with practice. After each lecture, the event recordings and summaries will be shared online to create a public library on sustainable business for everybody. If you missed our earlier talks, please do check out our recordings on YouTube and also summaries via the ECGI blogs. And then you can find some recent snapshots on the slide here. So for today, I know many of us have been very looking forward to the topic on nature and biodiversity. We're truly honored to welcome our academic speaker, Professor Johannes Stroebel, David Loeb, Professor of Finance at the University of New York Stern School of Business. So Professor Johannes is a globally recognized scholar in sustainable finance with influential work spanning across biodiversity finance, climate finance, and social networks. His research is widely published in the world's leading economics and finance journals, and he has also shaped the scholarly discussion through editorials at these journals, such as the American Economic Review, Journal of Political Economy, Econometrica, and the Journal of Finance. His outstanding contributions to this field have been recognized through numerous prestigious awards, among them most notably the 2023 Fisher-Black Prize awarded by the American Finance Association, which honors the leading financial economist under the age of 40. He's also a recipient of the Brattle Prize for the Best Paper published by the Journal of Finance, as well as the Moskowitz Prize for his work on biodiversity risk. Beyond his academic contributions, Professor Johannes is a prominent voice in the global finance and policy community. He serves as the director of the NYU Stern Climate Finance Initiative. He's also a research associate of the National Bureau of Economic Research, or NBER, in the US, and a research member of the Center for Economic Policy Research, or CEPR, in Europe. His work truly exemplifies how rigorous academic research can inform our real-world decision-making and drive meaningful societal impact, which strongly aligns with the aims of our lecture series. So today, our lecture format will be slightly different from our usual sessions. Instead of answering all the questions at the end, Professor Johannes will be also happy to address some of the questions during the lecture. So if you have any questions, please feel free to submit your questions at any time via the Zoom Q&A function. And also thanks to those who have already submitted the questions in the registration form. And our moderator, Tessa, will help service as many questions as possible throughout the session. And with that, let me also introduce our practitioner, speaker, and moderator today, Tessa Younger from CCLA Investment Management. Tessa leads CCLA's Better Environment work, overseeing stewardship on climate and nature to drive improvements at invested companies. She plays an active role in global biodiversity stewardship initiative, such as by serving on the advisory committee of PRI's Spring. If you don't know, PRI Spring is the largest collaborative engagement initiative on nature to date. She also is a member of the Institutional Investor Group on Climate Change, or IIGCC, UK Policy Working Group, supporting the dialogue on biodiversity and climate-related policy developments. Before joining CCLA about 3 years ago, Tessa was the head of engagement at PIRC in the UK. And during her time there, she led the local authority pension fund forums engagement and also co-developed the Say on Climate initiative, which encourages FTSE-listed companies to submit their climate transition plans for shareholder voting. So we're incredibly fortunate to have both Professor Johannes and Tessa with us today to share their latest insights on biodiversity and nature. So now, with that, let me pass the floor first to Professor Johannes to give us the lecture. So, Johannes, the floor is yours.
Perfect. Thank you so much for the kind introduction. And as was just mentioned, I think what we would want to do is I'm going to split the lecture into 3 parts. I'm going to take questions at the end of each of these parts. It's just going to make it a little more interactive. Otherwise, you're just going to hear me talk for 50 minutes, and I think you'll just get bored with this. So with this being said, what I want to talk about is a research journey that I've been on for the past 2.5, 3 years. That is trying to better understand the various ways in which nature and biodiversity loss interact with economic activity. And I started on this research journey because sort of for the previous decade, I'd been spending a lot of time trying to understand the relationship between climate change and economic activity, the two-way feedback loops. And for a longer time, I wasn't really sure about the various ways in which nature and biodiversity loss are sometimes distinct from the effects of climate change, or whether or not they're capturing the same types of economic forces. And so, as we all know, that biodiversity has been rapidly deteriorating due to human activity, and that has potentially large economic costs. So if you look, for example, at the ECB, the European Central Bank, and Frank Elderson, the vice chair of the supervisory board, has said that destroying nature means destroying the economy. And there are some prominent examples where there are large-scale social and economic losses from biodiversity loss. But there's also many examples where past species losses have had very little noticeable effect on economic output. And so that led me to kind of try and understand better why, in some cases, nature and biodiversity loss might have very large economic effects. In other cases, it might not have very large effect. And trying to dig a little bit into the economic modeling and the economic theory and data work to try and figure out whether it provides us any guidance. And in that work, I realized that certainly on the economic side, there's rather little work to help us try and understand these relationships, to help us try and understand really the role that biodiversity and nature have for economic activity. And so me and many others over the past few years have really engaged on this research journey to fill in some of these gaps. I think we've made some progress. I think this is also still a really new research field. So I think there's going to be many things where I'll have to say, I don't know yet. As a result, it's a great research field for young scholars to get into, because I think there's lots of open questions and lots of really important open questions. But what I want to do today is I want to summarize some of the recent progress that's been made in better understanding the economic and financial implications of nature and biodiversity loss. And I'm going to try and focus on 3 topics. And again, I'm going to, address them each one by one, and then open the floor for questions after each one of them. So the first one is the relationship between nature loss and climate change. Really trying to understand this question that I highlighted in the beginning, where I wasn't really sure whether or not they are distinct or whether they're really capturing the same thing. And I'm going to try and tell you what I think the ways in which they are truly distinct in their effects on the economy, and the ways in which they're intertwined. So that's going to be the first bit. The second bit is trying to understand physical biodiversity risk, right? Where does economic risk from biodiversity loss, and again, the focus here is going to be on diversity, so we're going to talk about species extinction. Where does that come from? And how does that help us think through this other question I just had, which is, well, sometimes we lose a species and it seems to be a really big deal for economic activity. And then other times we lose a species, and from at least an economic perspective, the effects seem to be pretty small. So I'm going to talk to you about what I think we've learned there over the last few years. And then lastly, I'm going to talk about the pricing of biodiversity risk exposures, and this could be both physical risk exposures, like the ones I'm going to talk about in the second part, or transition risk exposures, regulatory risk exposures across asset classes. How do you measure the exposure, and then can we find evidence that that exposure is already priced across asset classes? So that's going to be the three bits that I want to talk about today. Before I can do that, I need to introduce some terminology that might be familiar to many of you, but I think it's helpful to just start out with it in the beginning, which is I'm going to take the perspective, and I know it's a very partial perspective, but it's an economics and finance talk. So I'm going to take the perspective that nature, primarily contributes to human well-being through providing a whole range of ecosystem services. These will include what we can call provisioning services. So these are things where nature plays a direct role in, say, the production process through things like, producing food, producing raw materials such as timber, or raw materials and genetic information useful for pharmaceutical R&D, but also through what's called regulating or supporting services. These are things like pollination, seed dispersal, water filtration, etc. Things that might not directly be consumed by humans, but they sustain the whole ecosystem in a way that the provisioning services can work. I'm going to be upfront about the fact that there's obviously a huge debate about whether nature and individual species have sort of an intrinsic value beyond these sort of ecosystem services that they provide to us as humans. I'm going to sidestep that question because I think you can think about that question independently of sort of the role through ecosystem services. And because it is such a complex question, I think we understand so little even about the provision of ecosystem services that that's going to be the focus of today. That's not to diminish some of these other more intrinsic values. It's just that as economists, we have much less to say about that. And so, that's sort of for a different discussion. So let's start on this first topic, which is trying to better understand the relationship, the distinctions, but also the interactions between nature loss and climate change. And I'm going to introduce a very simple economic model based on a paper we published earlier last year that really tries to make that relationship clear. The paper is very short. It's only 5 or 6 pages long. So it's really a very stripped down version where we're really trying to figure out how can you write down the simplest model that we think captures some of the most important relationships between economic activity, nature, and climate change, and the ways that these three objects interact. So the model is going to be a 5-equation model. So what we're trying to do is just a 2-period model. We're going to try and maximize welfare, which is the utility of consuming today plus the discounted utility of consuming tomorrow. The second equation you see on the screen here is the first place where nature and climate change enter. So consumption today is a function of output, and output is produced by both capital and you can see here E0, which is what I mentioned before, some of these ecosystem services where nature directly enters into our production. So you can see this picture of a farm down here, but you can also think of timber or other factors of production. Then you can see that consumption tomorrow also depends on nature tomorrow. Again, nature is a factor of production. But importantly, here's the second place where nature and climate might interact with each other, which is through a damage function. So this is for those of you who are familiar in terms of how economists have been thinking about the effects of climate change on economic activity. We've usually done this through a damage function. So if you think about Bill Nordhaus's model, the DICE model, for which Bill Nordhaus won the Nobel Prize and which underlies many calculations of things like the social cost of carbon. The way we think about how climate change affects economic activity in those models is through a damage function. So we produce output, which is that F component at the end. And then at the end of the period, some of that output gets destroyed from climate damages. You can see, a picture of a hurricane here, but this could be wildfires, this could be droughts, this could be floods, whatever the physical hazard from climate change is. And so the more climate change we have, which we're going to, denote by Z1, climate change in the second period, the bigger the damages are. Okay. One important, I think, ingredient in trying to think about the nature-climate relationship is the second component here, where we've put the amount of nature also into the damage function. And what's really important here is that the damages are declining in how much nature there is. And what I've plotted down, well, here the picture is of a mangrove forest, where we all know that mangrove forests, for example, protect shorelines on hurricanes and other sort of climate related physical risk. Nature actually provides adaptation to climate change. And as we destroy nature, we're actually becoming increasingly increasingly, exposed to climate risks precisely because, nature itself provides us with adaptation against climate damages. So I think that's one really important dimension in which nature and climate change interact. It's climate damages, destroy economic output, but they destroy less economic output when we have more nature to provide us with nature-based adaptation. So that's the first three equations. The last two we need is the evolution of nature and climate change. So where does that Z1 and E1 come from? So where does the Z1 come from? So that's how much climate damages we have. Well, climate damages are both a factor of economic output, economic activity. This is something that's very familiar again from the DICE models. So the more capital we bring into today's period, the more carbon emissions we're going to have. And so that's going to drive climate change. So you can think about that theta K here to be a positive constant. But what's also really, really crucial is that the more nature we have, the less climate change we're going to have. Why? Because nature is a natural carbon sink through its photosynthesis, right? So what we're going to have here is the theta E is going to be negative, right? The more nature we have, the less climate damages we have. And as I said before, the more nature we have, the less damage the climate change that we have will cause because of its adaptation role. So two very distinct but important ways in which nature and climate change interact. What are the other two things? Well, the last equation we need is how much nature we have tomorrow. And I think here we are going to have nature being declining in the amount of capital, right? So the more economic activity we have, the more we destroy nature. Here's it's very simple. We just make it a function of capital. In the more extended model that we draw this from, we actually have land in there as well because, nature loss, the primary driver of nature loss is land use changes. Here, we're going to shortcut and just say the more capital we use, the more economic activity we have, the more nature gets destroyed. And then importantly, we're going to have the second part of the feedback loop, which is the more climate change we have, the less nature, because we also know that climate change is a driver of nature loss. So we have this two-way feedback loop that I'll come back to in just a slide or two between climate change destroys nature, and then the less nature we have, the less carbon sink we have, so the more climate change we're going to cause. So there's going to be this two-way feedback loop that comes on top of this nature as adaptation. So we think that these 5 equations capture a lot of the intuition about how physical climate change and nature loss are interacting with each other, but also distinct with each other. So this is just in some sense a graphical representation of the two. And I think what it highlights is that one of the central aspects of how nature is different is that it is a direct factor of production. The way that most people think about climate change, again, is through this damage function approach. So when we have more climate change, the underlying way in which the economy produces output remains unchanged. And it is only after output is produced, some of it gets destroyed by a hurricane or a wildfire. I think with nature, because these ecosystem services are a direct factor of production, when we lose nature, the ways it affects economic activity is much bigger. So what you see here again is you have capital on the left. Capital drives output, right? So that's kind of straightforward. Capital also drives climate change, and capital drives, that's kind of the arrow at the top. And then capital drives nature loss, that's the arrow at the bottom. Then nature loss and climate change interact with each other. Climate change destroys some output. Nature reduces how much climate change destroys output. And then nature itself is necessary in the production of output. Right. So this simple model, again, just 5 equations. So for most economic models, this is, would be characterized as a second-year homework exercise rather than some sort of, sophisticated frontier model. But I think it was actually very hard for us to kind of slim down these sort of complex ways in which it interacts into a simple model. Delivers, I think, several really interesting insights. So the first really, really interesting insight to us is on the substitutability between nature and capital. So what do I mean by that? I think a lot of people understand that these ecosystem services that nature provides are important to us. But quite frequently you hear that, humans are becoming better and better at substituting for what nature does for economic activity with physical capital. So the idea is, yes, nature does provide water filtration, but we can do mechanical water filtration. Right? You can have desalination plants and water filtration plants, etc. Or you say, well, nature is really crucial in pharmaceutical R&D, And people say, yes, but the new AI technologies replace a lot of the role of nature in physical R&D. Or you have people say, well, nature might be really crucial for for photosynthesis, for carbon capture, but maybe carbon capture and storage, these types of technologies are going to become very good very quickly. And so again, we're going to be replacing nature. So this big concern for a long time was that nature did something that was irreplaceable with physical capital. And so if nature went away, economic activity would have to decline because there was no other way to make good for it. So if that's I guess what we're learning here is that even if that is the case, right? And I guess it's a big if, and I think some of the functions of nature are more easily replaceable by physical capital and others are not. But even if you could replace what nature does with physical capital, what's really crucial here is that you take a factor of production like nature that is carbon negative, and you will almost necessarily replace it with a factor of production that's carbon positive. So take a forest that does your water filtration. The forest does water filtration and sucks carbon out of the atmosphere. If you're going to replace it with a desalination plant or water filtration plant, that might also clean the water, but it's going to put carbon into the atmosphere. It's going to be energy intensive, right? And so that sort of, nature is not just a factor of production, but it's a clean factor of production. It's a carbon negative factor of production. And even if we were able to replace some of these ecosystem services with, sort of physical capital, it would be leading to more climate change, not less. So the first aspect here, I guess, is once you understand this relationship between nature loss and climate change, you start realizing that, that even if it was replaceable, unless you've solved the climate problem, you're just going to make that worse. So that's, I think, one insight you get here. The other thing that I think you get out of this is that the net damages from nature loss might be a lot larger than what the direct damages imply. So what do I mean by that? By that, I mean this sort of two-way feedback loop between nature loss and climate change. I said this before, nature loss causes climate change because we destroy carbon things. And then climate change leads to more nature loss, which leads again to more climate change and so on. That's this component here on the right that I've now circled yellow, this two-way feedback loop between climate change and nature loss, which we've called the twin crisis multiplier. Because sometimes in the COP announcement, the nature crisis and the climate crisis are called the twin crisis. And I think here we're very clear why the twins are closely related, because there is this two-way feedback loop between them. Right. It also tells us that maybe some of the calculations of the social cost of carbon might be understating the true cost, because a ton of carbon in the atmosphere causes nature loss, which releases additional carbon into the atmosphere. So each ton you release might on net release more than a total ton through this, again, twin crisis multiplier feedback loop. So these are just two things that immediately jump out of you from this very, very simple model that help us understand a little bit about both how nature loss and climate change are distinct, but how they're definitely intertwined and they definitely interact with each other, and they interact with each other in ways that help us understand the total effects on economic output of each of the two forces is going to be bigger than if you just consider them in isolation or if you consider them from a very partial perspective. Okay, so again, it's a very simple model. It then captures some of the important things about how nature and climate change interact, both in terms of the twin crisis multiplier and in terms of how they both enter the damage function, with climate change causing more damages and nature loss causing less damages. And I hope it kind of provides us a starting point to become both clearer in our communication, because I sometimes think part of the reason I was so confused about whether or not they're the same or whether they're distinct is because when I was talking to people and I was attending industry panels and so on, I think sometimes we're a little sloppy about them. We go back and forth as if they're the same thing. I think it is helpful to be clear and precise about how they are different. Because I think once you realize that this twin crisis multiplier actually shows us that the problem is probably even bigger than if you think of them in isolation. So that's the end of the first topic. And as we said, I think we're going to see if people have any questions on this before we move on to the next one.
So I can't see myself on screen, but this is Tessa, and I'm very pleased to be here and to moderate for this session. So today's discussion matters because nature-related impacts are increasingly showing up as financial impacts, and they're poorly understood and unevenly accounted for. But let's jump straight into the questions, which I think is a great way to run this. The first would be, Johan, if we aggressively rehabilitate nature, if we think about this, we can increase our carbon sinks, and may that reduce the quantum of emission factors we use for operational emission calculations. And I'll also give you a second question just to think about both and answer both, which is, how different is biodiversity from climate change? You spoke about that quite a bit, but aren't they driven by the same factors, and maybe really address the change in biodiversity and change in climate change?
Yeah, so it's two good questions. So let me maybe on the first one, I completely agree, right? So this twin crisis multiplier goes both ways, right? So if we destroy nature, we cause more climate change, which destroys more nature. On the flip side, if we rehabilitate nature, we're going to reduce climate change, and we're going to therefore slow down the rate of future climate-driven nature loss. Right. So I think you can think about this as a vicious cycle, but you can also think about this as a virtuous cycle for restoration. And I think that can be a very helpful way to think about it. And maybe the total benefits from restoration, once viewed through this twin crisis multiplier lens, can actually be bigger than, if you just think of a restoration in isolation. So I completely agree with that sentiment. In terms of, are they distinct? Are they different? Are they not driven by some of the same forces? I mean, I think yes, they are in many ways driven by some of the same forces. And I think, this sort of very simple model here makes that clear, right? Like the capital, the economic activity drives both climate change and nature loss, right? Now, if you think about a more complex world, you might say, nature loss is maybe slightly more driven by land use changes, while climate change, can result from, economic activity that doesn't necessarily require us to change land use all that much. But I think first order, it is us humans and, our expanding economic activity that is a driver of both of them, right? And I think that's why they're intertwined in important ways, right? But I also think that, the distinct, so no, they're not completely distinct. But I think they are distinct in the way that they affect economic activity, because nature is directly a factor of production, right? And I think, it's maybe very obvious when you say it. It took us a while to really wrap our head around that kind of being the crucial distinction. Now, you might say, well, maybe climate change should also be considered a factor of production, not just through this lens of a damage function. But I think this idea that, without food or without, some of the raw materials we get from nature, there would be no economic activity, because some of the things that nature does there are at the moment still irreplaceable with other factors of production. I don't think that same sort of very strong statement would apply to climate change as a problem.
Yeah. That's really helpful. We've got lots of questions in the chat, but to keep us to time, I think I'll ask you to go on to the next session and go deeper into physical biodiversity risk and ecosystem fragility.
Perfect, thank you. And then we can also come back to some of the other questions at the end.
Exactly.
Okay, so the second type of question relates really to this sort of puzzle that I started out with in the beginning, which is, you have people saying destroying nature means destroying the economy. You can also say, well, we've lost a lot of nature over the past 50 years, right? I think that's undeniable. And yet, I've struggled to come up with sort of very coherent stories, at least initially, about how the world economy today would look different if we hadn't destroyed all this nature. And I've put this question to many people who've gone very strongly and said destroying nature will destroy the economy. Say, tell me concretely how this dramatic destruction of nature that we've just talked about, how the world economy would look different today if that hadn't occurred. And it's actually quite tricky to do. It's actually quite tricky to answer. So that was kind of a second research path I've been on, trying to really understand that. And maybe take a step back, because I think a lot of you from a practitioner perspective, always wonder about this, how much risk does nature loss cause for an economy or for firms? And those of you who come from a risk management background or risk management, sort of training, will be very familiar with this sort of, distinction that people have in that space. When you think about risk being driven by an interaction between hazard and vulnerability. And in particular, what we want to focus on here is hazard. What are plausible scenarios for nature loss and associated probabilities? And what we want to do here is want to focus on one key aspect of nature loss, which is the biodiversity loss or species extinction, right? You can think about, this is actually one other thing where I think we're sometimes a little sloppy in our language. We use nature loss and biodiversity loss almost interchangeably. Well, when you think about biodiversity loss, almost by definition, what you're going to be talking about is the distinct number of unique species out there. That's at least the most common definition of what people have in mind with biodiversity loss. And so in another research paper, the economics of biodiversity loss, what we do is we try and really dig into the ecology literature to help us try and understand why it is that sometimes when you lose a species, you have very large economic effects. And then other times when you lose a species, the effects seem to be rather small or hard to capture. So what we're going to do is we're going to propose a specification of how diverse species interact with each other to produce ecosystem services, right? So if you think about the prior model I had, right, there were no role for different species. It was just nature would produce this aggregate E, this total flow of ecosystem services that comes out of nature. What we're going to do here is trying to break that up. Where does that E come from, and how do different species contribute to that E to help us understand the role of biodiversity, the interaction of unique species? We're going to try and write down a model, again, that captures the main features documented in the ecology literature. We're going to try and make it tractable enough so that you can integrate it into more complex economics models. I think that's going to be very helpful for end users, say at central banks or other regulators that are trying to not just model the ecosystem, but try and understand the relationships between the ecosystem and broader economic activity. And the key idea here is that you can't just think of nature as one stock of natural capital, but you need to think about it as the complex interactions of many, many different species. And what's going to turn out is that the type of model that we're going to settle on, which again, we didn't start with, but we started out with spending 3 months, reading hundreds of papers in ecology, attending undergraduate lectures in ecology to really try and understand what do ecologists tell us about the role that different species play. But as we kind of went through that process of learning actually fairly basic ecology. So again, the ecology behind this here is not PhD level frontier ecology, it's undergraduate ecology, right? So this is rather settled material within that field. But as we were thinking about this, it sounded to us like the way an ecosystem looked was actually not that different to the way a modern economy looks. And so we've come to believe that you can use a lot of the tools of abstraction that we've built in modern macroeconomics to apply to give us a better understanding of how ecosystem works. And so I want to walk you through that and why I think that is the case. So again, what we're going to do is rather than focusing on this E, this sort of, ecosystem services in my previous very simple model, as an aggregated natural capital, we disaggregate it into its ecological elements. And what we're going to do is we're going to use a hierarchical model. So we're going to say the E is made up, a whole ecosystem's output is made up of a bunch of what we're going to call functional groups that include different species that fulfill rather similar primary ecosystem services. And then we're going to look at diversity of species within each of these functional groups. So let me be sort of concrete here, right? So remember this at the top here, the Y, that's the aggregate production function we had before. So, output is a function of, capital and this nature. So what we're going to do is in the first level, we're going to have all of these different ecosystem functions. So these are things that need to be fulfilled in an ecosystem for an ecosystem to work well. So this could be things like pollination or seed dispersal or clean water provision or pest regulation or something like that. And what we're going to do is we're going to say that, the total output of an ecosystem is a CS aggregator. That's the equation we have on the right here. For those of you, who are not familiar with these types of aggregators, I know we have a mix of, academics who are very familiar with these types of specifications and practitioners who might not be. I'll try and give you an intuition of what it does. But for those of you who are familiar with a CS aggregator in macroeconomics, we're going to aggregate over the different ecosystem services, but we're going to have a very low elasticity of substitution. So we're going to say that there is complementarities between these ecosystem functions. What does that mean? What it means is that an ecosystem is very, very hard to sustain when any one of these key functions is missing, right? So you can't have an ecosystem where there's no pollination. If like pollination goes to zero, it doesn't really matter how much you have of the rest. The ecosystem is unlikely to be healthy. Similar if you have no pest regulation in an ecosystem, right? Again, the ecosystem is going to be very unhealthy. And what's really crucial here is that you cannot easily compensate for the loss of one function with the increase in another, right? So you can't just say, oh, well, we've lost all of our pollinators, but, we're very lucky because we've doubled the number of pest control species. Well, that's not going to be very good because you need each of these functions to be present for the overall ecosystem to function, right? And as I said before, that's very similar to the way we like to think about industries in an economy, right? So an economy is made up of lots of different industries. There's an energy industry, and then there's a banking sector, and so on. And you need all of them to be present for an economy to function, right? You can't just say, well, we're going to wipe out all energy firms, but we're just going to build more banks and we're going to function as well. No, like energy is a crucial component of an economy. And if there is no energy, then we can't run the economy independently of how many banks we have, right? So that's the kind of idea that we're borrowing from macroeconomics in the way we model. But the underlying idea here is something that's very familiar in the ecology literature. So for example, you find this in a lot of empirical work in ecology. So here's just one example. But there's thousands of these types of papers out there from Sutter and Albrecht who basically report in their experimental work that they find strong synergistic effects of insect pollination and pest control. So they basically tell us if we double insect pollination, you get an increase in agricultural yields of 7%. When you double pest control, you get an increase of 6%. Right. So then the question was, well, if you double both of them, what would you get? Well, initially you would say, well, you should add up the 7 and the 6%. Right. So you'd expect 13%. It turns out that when you do double both of them, you end up getting 23%. Right. So there's a synergistic effect. The more you have of one, the more productive the other becomes. But similarly, the less you have of one, the less productive the other becomes. And that's exactly what you would get when you have these very low elasticities of substitution. You can do a back of the envelope calculation. These estimates here get you a sigma of 0.1 between insect pollination and pest control. So very low elasticities of substitution. Again, very consistent with this underlying idea that you can't just, say, well, we're going to have less pest control, but, let's just double insect pollination and we're going to end up with the same overall output of an ecosystem. Okay, so that's this first level where you have ecosystem functions. And then the second level then becomes is that each ecosystem functions is going to be potentially provided by many, many different species. And here the ecologists have a very, very strong empirical relationship that they found, which is that within each ecosystem function, the output follows what the ecologists call the biodiversity productivity relationship, which is that the output of an ecosystem function is increasing and concave in biodiversity, where again, biodiversity is the number of unique species. So there's a lot of experimental work in that space. There's also a lot of observational work in that space. I have a picture down here just from a fairly recent paper in Science that does an observational study for tree species diversity. And it finds exactly that forests that are more diverse in terms of tree species richness, they are more productive in terms of total biomass produced, where again, the relationship is increasing, but it is concave. Now, the ecologists haven't just established this as an empirical pattern. They've also understood the underlying mechanics behind this. And it comes down to what the ecologists call niche differentiation. This is very similar to an economist's use of the term product differentiation. So what is niche differentiation? Niche differentiation is basically the idea that every species crowds out members of its own species more than it crowds out members of other species. Think about the following, right? If you think about, if you just have one type of species, they all have roots of the exact same length underground. So they all compete for resources at the exact same length underground and basically just get in each other's way a lot. On the other hand, if you have two species, One species might have very short roots, one species might have very long roots. Those two species are much better at extracting the total amount of resources out of the ground than if you just have one species type, precisely because they're differentiated in the way that they use resources. Similar with trees, if they all have crowns of the same height, they take light away from each other. But if you have crowns of very different heights, you're better able to absorb more of the available light, more of the available resources, and therefore you can be more productive. So this niche differentiation is very naturally leading to this concave biodiversity productivity relationship. Why is it concave? Well, at some point, you basically have so many species that you've already extracted almost all the resources that, you know, an environment provides, right? So again, if you have already enough plants that you have root length at every sort of, you know, at every distance underground, you have extracted all the nitrogen there is in the soil. And so adding one more species doesn't really add to the overall productivity. Right. So going from 1 to 2 species adds much more to the overall productivity than going from 20 to 21 species. Okay. So this is a very clear pattern in the ecology literature. How we're going to represent that? We're going to represent that through another CS aggregator, aggregating the different species within a function. So the different pollinators, for example. But now we're going to have a much higher but still finite elasticity of substitution. And again, the idea here is to just take what the ecologists have taught us and trying to turn it into a useful framework for economists and others to think about, and just to convince you that, you know, I know if you look at this, you think this is completely crazy. How can this be useful? Just to say, we've been working, for example, with the Asian Development Bank for their Asia Pacific Climate Report, and they've included this exact way of thinking about an ecosystem, you know, in their section on how to account for nature's value, right? So I really do think there's something useful in here, because as economists, we are very good at taking this type of nested CS and incorporating into essentially all other types of frameworks that we're building. And so I think, you know, again, taking something as complex as an ecosystem and trying to simplify it down into this sort of simple hierarchical model where you have ecosystems, functions, and species, I think can be quite productive. One caveat here is that when we initially talked to a lot of ecologists, you know, they said, this is going to be impossible. Right? The ecosystem is so complex and everything interacts with everything and nobody can ever make any sense of this. And, you know, we said, I get that, but you know what? Like, the world economy is also super complex, right? There's millions of firms and billions of workers and lots of trade flows and, you know, millions of prices and lots of interactions and so on, right? So it's not like the world economy is a very simple object. And yet, I think as economists, we're sort of trained to try and come up with degrees of abstraction of a very complex object like the world economy to break it down into something that's useful for understanding, say, the role of different firms in the economy, right? And I think while, you know, while I'm very sympathetic to the view that, yes, isn't an ecosystem so highly complex that you can never capture everything? It's like, the economy is also very complex that you can never capture everything. And yet I think abstraction is valuable, abstraction is useful, it's helpful to make progress on these types of questions. I'm going to show you how this model delivers some very useful insights to help us think through about exactly this question about the role of different types of species, okay? Okay, so now that we can use this model to study how shocks to biodiversity in a given function affect total ecosystem service production. This is just, you know, I'm just crossed out like one N here. This basically, we lose a given species, what is going to be the effect on overall ecosystem service production? So here is, again, this concave within function biodiversity relationship. And now the way you want to think about this is you want to think about losing a species as going from right to left. So you start from maximal biodiversity, which is sort of the way the economy looks today. And each species you lose moves you slightly further to the left in this graph here. This is within a function, right? So imagine this is the function pollination. So when you start out with lots and lots of pollinators, you're at the right, you lose a pollinator, you're going to have a relatively small loss of the total output in pollination. Why? Because there's lots of other pollinators still around. They all kind of do somewhat similar things. Yes, it's not perfect. Maybe the one we lose loves to operate at a very particular temperature, and so maybe the others don't like to be quite as active at that temperature. So yes, we're going to see a decline in output, but initially the decline in output is small. Why? Because we have a lot of functional redundancy in there. Think about the following. Think about an economy where you have 20 energy firms out there. Yes, the first energy firm you lose isn't that big of a deal. Why? Because you have 19 other ones left. They can grow a little bit. They can make up some of that supply loss that you get from the one that you have, and it's not that big of a deal, right? But as you lose more and more species, as you lose more and more pollinators, you go further to the left, you see that the loss of each additional pollinator will lead to a larger and larger decline in pollination services, right? The same way that we had before, that if you go from 1 to 2 species, you're much better at extracting resources, and therefore you get a lot of output gains. And when you go from 19 to 20, you don't. It's the exact reverse of that. Moreover, I think because you have this concavity within functional groups, right? You have that each of these functional groups is complementary to each other. What you're going to get is that the overall loss of ecosystem production might actually be less than what you get in the function where you're losing. And so I think the intuition I have here, or the best intuition I have here, is if you go to the extreme version of that aggregation across the ecosystem functions, which is the min operator. So basically you say the output of the ecosystem is basically the minimal output of all of the functions. Right, so it's the bottleneck function is the one that is least productive, and the overall ecosystem can't be more productive than the output of the least productive function, right? If that's the case, what you can have is that, imagine that, the least productive function is at S minus G, right? And what you're doing is, even as you're starting to lose pollination services, when you go from SG, S bar G to the left, even as you start losing pollination services, you're not actually losing overall ecosystem service production, because pollination is not yet the constraining output on the overall ecosystem. The problem is when you hit the point where pollination becomes the constraining force, you can get very, very sharp declines in overall ecosystem service production from declines in pollination. And so what are the implications? I think there's 3 crucial implications here for me. The first implication is that, what you might have is that initial losses of species may have very, very small effects on output only, but they make the ecosystem more exposed to further losses. They increase what we call ecosystem fragility, because while, moving from the right to the left initially doesn't reduce output a lot, every loss of a species means that the next species you lose will have a larger and larger and larger effect on ecosystem service production. The second implication, and I think here is something very crucial to that initial motivation we had, which is there's a huge asymmetry in the effect that different types of species loss will have on overall ecosystem service production. And in particular, what you're going to have is you're going to have the emergence of what ecologists call keystone species. So keystone species are in some sense the last species that's left fulfilling a certain function in an ecosystem. Right. And when you lose a keystone species in an ecosystem, right, at that point, the overall economic effects can be very large. Again, think back to the example of the economy. The first 5 or 6 energy firms you lose when you start with 20, probably not that big of a deal in terms of how the economy can function. But the last energy firm, when you lose that, you go from having an economy that has 1 firm producing energy, so there is energy being produced, to having no energy whatsoever. And so it's the same thing, right? When you start with 20 pollinators, going down to 19, 18, 17 is not that big of a deal. When you have 1 pollinator left and you lose that one, you're going to have a huge decline in the overall health of the ecosystem. Why? If you think back to that complementarity of the functions, there's no way that you can make up for the loss of pollination service. You can't just say, well, we're going to have lots of other species that do other stuff. Well, that's not very helpful. You need each of these functions to be provided for an ecosystem to be healthy, right? And this is, again, exactly tells us why sometimes you can find examples like in this AR paper by Frank and Sudarshan, where they find that, the loss of vultures in India, and again, it's interesting, they say in their paper they had no functional replacement, leads to very, very large economic losses. And in other cases, you lose species where the economic losses, at least the immediate ones, seem very small. It's precisely because those immediate economic losses are much larger when you lose a keystone species than when you lose a species that has much more functional replacement. But what we can't forget is that when we lose species that have lots of functional replacement, we make the ecosystem more fragile to future losses. Okay? The last implication here is on a topic that I think some of you might be interested in, which is the topic of ecosystem of biodiversity offsets, right? So in a lot of markets, and I know Tessa's in the UK. The UK has a biodiversity offset scheme, like a mandated one for development. So I think it's very advanced in terms of requiring biodiversity offsets. But the idea basically is to go and to producers of ecological damages, and you say, okay, we don't want to stop your economic activity entirely. Right, that would be sort of very costly from an economic perspective. But we require you to offset your ecosystem or your biodiversity losses in the place where you operate by doing some sort of, restoration or protection somewhere else. And I think what's really crucial here is to realize that that's actually very difficult. And I guess the idea here comes from carbon offsets, which I think most of you are familiar with, where the idea is if I could credibly, and again, credibly is important here, but let's put that aside. If I could credibly ensure that I stop a ton of carbon to go in the atmosphere somewhere in the world, that can, in principle, offset me putting 1 ton of carbon in the atmosphere, right? Because a ton of carbon is a common unit of account that that allows that type of comparison. A ton of carbon anywhere in the world is approximately the same climate implications. That's not the case for biodiversity. I can't just say, well, I'm going to destroy this wetland here, I'm going to protect another wetland somewhere else, because the role that each of these wetlands play in their ecosystems are very different. You can't even say, I'm going to, protect, my activities here might harm species A, I'm going to protect the same species somewhere else, because that species that you're harming in a given place might be a keystone species in that ecosystem, and protecting it in another ecosystem where you have a lot of functional replacement doesn't really lead to no net loss of of biodiversity, right? And so what's really different, it makes it just very, very hard. It makes you realize that biodiversity has no common unit of account. And because it has no common unit of account, because different species have different roles in an ecosystem, and even the same species might have very different marginal economic value across ecosystem, makes it really, really hard to think about biodiversity offsets. And just kind of turn this into something more practical. A few days ago, I wrote a case study in the FT to kind of take these insights from this more complex model and kind of walk through a case study using an example from Rio Tinto's biodiversity offsetting practices to walk through some of both the promises, but also some of the pitfalls of biodiversity offsets. And again, the central sentence is here. Biodiversity has no unit of account. Ecological value depends on factors such as species composition and ecosystem fragility. They're really hard to represent in simple scores that would actually allow you to do this type of comparison across settings. So for those of you who are active in the biodiversity offsetting space, have a look at this, this case study, which takes this maybe somewhat more abstract model and really tries to turn it into some sort of practical, useful guidelines for practitioners. So again, we've worked, and just one other thing I want to point you out to, as part of this ADB work, we've tried to kind of take this framework and calculate a concept called ecosystem fragility, which basically tries to measure aggregate physical biodiversity risk scores based on how uneven biodiversity loss has been across functions. So again, the idea is that an ecosystem where you've lost 10% of species, might be much more fragile when you've lost 50% of species in one function and none in another, versus an ecosystem where every function loses 10% of species, right? So what's really costly for an ecosystem is to have some functions that are near depleted, where, you're really going to start having, some functions become almost, some species almost become keystone species, where if you were to lose those, the economic effects would be very, very large. So again, this ecosystem fragility concept is the sensitivity of ecosystem services to a loss in biodiversity, a further loss in biodiversity. And it depends both on how depleted an ecosystem is on average, but also how uneven the depletion has been across functions. And again, in this paper here that I can point you towards, which the Asian Development Bank has integrated into its report, we kind of try and work with ecological data to try and make this basic insight tractable. Can you actually measure some of these things? Can you actually say which ecosystems are more fragile than others based on this imbalance across functions? So that's a second topic that I had, trying to understand why sometimes some species have different role than others and what that means for things like, biodiversity offsets, but also just the general understanding when people push you and say, well, you've told me we've lost so many species. How would the world economy look different today? And you say, well, luckily we've started out with a very rich ecosystem. So the species we've lost many of them had functional replacements in their ecosystem, but we've now arrived at a point where we've depleted it so much that the remaining species are becoming increasingly keystone species in their ecosystems. And so just because past ecosystem service losses haven't had large economic effects doesn't mean that future losses won't have large economic effects. Okay, and I'm going to stop here again to see if there's any questions or if Tessa has anything.
Oh, thanks so much, Johan. That is so rich. And I loved your translation for non-academics of CES aggregates and niche differentiation. I think you need to do a chart for me in terms of sort of knowledge accretion or something with a lovely curve going up. But trying to keep to time, we've got so many questions. I really just have to pick out a couple. So the first one, I'm quite interested because I'm very interested in climate tipping points and the materiality of that is, given ecological tipping points and non-linear dynamics, how should financial models account for biodiversity risks that may not follow linear or normally distributed loss patterns? And then a second question I picked out that I thought was quite interesting. How do we incentivize biodiversity conservation if there isn't a common unit to measure biodiversity?
Yeah, very good question. So first on the tipping points, I love that question because what actually comes out of this model, if you say follow the red line, which is really aggregate ecosystem service production, as you lose, say, pollinators, you see exactly something that does look very much like certainly a non-linearity, right, in the system, right? So you find that initially biodiversity loss in this function has almost no effects on ecosystem service production, and then when you hit that sort of and call it tipping point, you start seeing very large ones. So I think you need to think about nonlinearities. And what's really nice is that these nonlinearities come very, very naturally out of the ecology literature, and they're fully represented in this model that we have here. So I think if you take this model and you integrate it into others, you are very, very naturally going to get nonlinearities in your in your assessment, right? So you can see, I mean, this is it's a flat line and then it becomes very steep downwards. So this is, with the extreme version of a nonlinearity in there, right? So yes, there are these nonlinearities, and they're exactly there because of this concavity in the biodiversity productivity relationship that the ecologists have established. So I think that's a very good point. On the other question about how you think about the financing of nature in the absence of this common unit of account, it's tricky. I think so I think the way that the way that the UK system works is, at a minimum, it requires like-for-like offsets, right? So you can't just say I'm going to destroy a wetland and as a result, and I'm going to reforest somewhere else. No, if you destroy a wetland, you got to protect a wetland, right? So it makes it more common. It also incorporates multipliers to account for uncertainty. Right. So the idea would be that you do because you do one wetland, you need to do a 1.1. Like a 10% increase in what you restore to account for that. So that is at least one way of making it still an investable or a tradable or an asset class in nature. The way it has worked in practice so far is that, to the extent nature protection has been monetizable, at least in the past, it's been through its role in terms of carbon capture, where again, you have the common unit of account. I think that's a very narrow way to think about the role of nature. Again, if you think back to the very first model I put on the table, it was very clear there that, carbon sequestration was one of the roles that nature played, but it wasn't the only valuable addition to the economy. And so I think what we need to do is we need to start taking models like this one serious, right? Which means you can actually turn nature into a common unit of account, which is, what is the role of this species, which is exactly, if this species goes away at the margin, what is the effect on economic activity, right? And it is just realizing that even for the same species doesn't have to be the same across two ecosystems, because it depends on how much functional redundancy there is across the two ecosystems. So it doesn't mean that that you can't think of a common unit of account. And in fact, part of the reason what we're trying to do in this model and in some of these calculations is to exactly trying to put units of account on there. But the unit of account is a more complex one, because the unit of account, or the value, say, of a given species in an ecosystem can't be seen independently of what else there is in that ecosystem, right? Which makes it more complex to think about what the value is, but it doesn't make it impossible. Now, the question is, does it make it so complex that it is in fact impractical? And I think I haven't quite figured out where I land on that. I think it would be very useful to try and do this, and maybe we have to go somewhere in between, right? But again, I think this idea that you can just offset some harm done somewhere by, reforesting or protecting or restoring somewhere else without trying to figure out how crucial what you destroy is to the local ecosystem versus what you protect or reforest is to the ecosystem, I think it's just missing a crucial aspect of what the ecologists tell us is really important. And, just makes this potentially not, makes it something that's very expensive without potentially meaningful ecological benefits. Right.
Thanks for that, Johannes. I think one thing is clear how complex this all is, and balancing the different factors. So with that foundation, let's go to the final section on what this means for markets and pricing across asset classes.
Perfect. Yeah, thank you. So the last set of questions, and this is sort of maybe more traditional of what we think about in finance departments, is to try and understand, whether or not asset prices reflect, firm exposures to biodiversity risks. And again, the way you can think about this is either you can think about exposure to physical risks due to dependencies on nature, or you can think about regulatory or transition risks due to impacts on nature, right? So as a firm, you might be affected because you use a lot of nature in your production, or you might be affected because you destroy a lot of nature in your activities and you're worried about that getting regulated. Now, the question, that's an important question, because, these types of price effects are central to disciplining financial markets. But also unpriced or underpriced risks here might be a source of financial stability or financial instability, financial stability risks. So the way that, people in asset prices or in asset pricing usually try and approach these types of questions is twofold. Both of them require you to be able to tell firms apart based on their exposure. And I'll talk a little bit about what can be done there. How can you figure out which firms are exposed to either one of these two types of biodiversity risk? But once you have, this type of exposure, you can form what we call long-short portfolios. So you go long the firms that are not exposed and short the firms that are exposed. And then you can ask two types of questions. The first one is, you can ask whether or not this has a beta with respect to realizations of news about biodiversity risk. What do I mean by that? I mean by that when we get bad news about biodiversity risk, right, like aggregate biodiversity loss is bigger than we thought, is it the case that those firms that are more exposed lose in value, and those firms that are less exposed gain in value relatively? And that would be, an indication that financial markets are taking biodiversity risk exposures into account. The second thing that you could do is you could look at whether or not the more exposed assets have higher realized returns, because the idea would be, well, if it's risky, right, then there should be a risk premium associated with it. And so the more exposed firms should have a higher expected return to compensate for that risk. The problem is we can never measure expected returns. We can only ever measure realized returns. And to measure realized returns well, you need decades worth of data. I don't think biodiversity risk is something that's been priced for many decades. And so the second approach, I think, is not very productive, trying to figure out whether or not there's a risk premium associated with it, because means in time series data are really hard to estimate. Variances and covariances are much easier to estimate. And so I'm going to talk about a few approaches of that first step, right? Trying to figure out if there's a beta with respect to realizations about news about biodiversity risk. So what we did in this research agenda is we first built an index of biodiversity news or biodiversity risk. So this is basically, we went through the New York Times and every day, and we basically identified articles that talk about various types of biodiversity risk. And then we coded those articles based on their sentiment to figure out when are days when there's an increase in biodiversity risk and when are there days where there's a decrease in biodiversity risk. And I want to point you to this website, biodiversityrisk.org, where we're sharing all of this data that I'm going to talk about for the next 5 minutes. You can just download it, replicate the work we do, use it in your own work, and so on. And then the second question is, how do you calculate, say, country level biodiversity risk exposure? I hinted at this already before. What you need to do is you need to measure imbalances in species loss across functions. And in the interest of time, I'm not going to walk you through all the things that we do here, but basically, we start with a data set that has lots of species level extinction data. We group different species that fulfill the same ecological function together. So on the left hand, you see a bunch of species that are all seed dispersers. On the right, you see a bunch of functions that are all, controlling plant growth and prey species in terms of their function for the ecosystem. And then we calculate for each country and each function what has been the loss of biodiversity since 2000 using data from this data set called the Map of Life Project. It's a team of ecologists at Yale University that provides species by species level extinction and habitat loss data. And we basically map the species to their functions, and then we look at function level declines. And what you can see, for example, is that, just as an example, Nicaragua and Guatemala, they've both had sort of similar average biodiversity loss. But what you can find is that Nicaragua has had much more dispersed biodiversity loss across functions than Guatemala had. And again, through the lens of this model that we introduced before, Nicaragua should be much more sensitive to future biodiversity loss, because in some functions, you already have destroyed a good chunk of the biodiversity that you have, and therefore you're more sensitive to future losses. And so what we then do is we test whether or not this type of biodiversity risk exposure, both how much you've lost on average, but also how dispersed the loss has been across function, whether or not this is priced in sovereign credit default swap spreads. And again, I'm just going to tell you what we do roughly, and you can look at the research paper if you're interested in the details. But we basically find that during periods when there's this aggregate negative biodiversity news, so when the New York Times writes about biodiversity risk increasing, during those periods, the CDS of countries like Nicaragua that are more exposed, they go up by a little bit more than that of countries that are less exposed. So it does look like, the people pricing sovereign CDS are aware that there's some countries like Nicaragua where the ecosystem is already much more fragile, precisely because there are some functions that are extremely depleted. And that does seem to be reflected in prices. Now, the magnitude of the reflection in prices is tiny, right? So we're talking about single-digit basis points movements in the CDS. And again, you can look at the paper if you're interested in this. But I think it is something where it does seem to be that it is started to get reflected in prices. We also look at the risk exposure across firms when we start looking at stock prices, so not just CDS, but also stock prices. So again, we're trying to measure physical risks and regulatory risks. And what we do in this paper here is we're trying to measure firm level risk exposures via their self-disclosures in 10K statements. And again, we have all the firm level risk exposure data at biodiversityrisk.org. So for those of you who are interested in this, but basically what we're going to do is we look at each 10K statement and we say, is this firm telling its investors that it is exposed to some type of biodiversity risk? What you find is that these types of disclosures have been increasing over time. So, by now about 5% of firms explicitly mention biodiversity risk exposures in their 10K disclosures to their investors. That's up from about 1% 25 years ago. And what you find also is that there's a big difference across sectors. So the energy sector or the utility sector, real estate, food, beverage, tobacco, pharma, biotech, those are the sectors that are most exposed based on their self-disclosures to the various types of biodiversity risks. But things like communication and software is less exposed. How are they exposed? I'm just going to give you some very small examples. So in the energy sector, right, Cheniere Energy says if one of our LNG terminals may adversely affect a protected species or its habitat, we may be required to develop and follow a plan to avoid these impacts, right? So this is clearly someone who is, who's talking about exposure to transition risk, biodiversity transition risk. Let me just give you one example from the pharma biotech sector, right? This company says we focus on the use of biodiversity as a means of natural product drug discovery while also using traditional techniques, right? So this is a firm that's telling us that biodiversity is a crucial input into its production, and therefore the firm might be exposed to, to physical biodiversity risk, right? So again, an example, and again, in the paper, we have lots and lots of examples from lots and lots of sectors. So not just the aggregate numbers, but you can also dig into how different firms and different sectors talk about their various exposures to these risks. Just one last example, this is from a shipping company that says, the protection of endangered and threatened species may include restrictions on the speed of vessels in certain ocean waters, may require us to change routes. The reduced speed and special routing will affect our operations, right? So again, this is very much a transition risk. A company that would disturb protected species, as that regulation might go up, this company might be affected. Just one very small, interesting tidbit here that I think is relevant for, in particular, those of you who are in the practitioner sector, is that, when we talked before about how biodiversity risk and climate risk are different, one thing that was very salient looking at these descriptions is that biodiversity and climate transition risk exposures are highly distinct. In fact, the sector among the one or two, among the 2 or 3 most exposed sectors to biodiversity transition risk is renewable energy companies. Those that would benefit the most from climate transition risk realizations actually hurt the most from nature protection, right? Because, wind farms kill birds, hydropower makes it hard for migrating fish, the land use requirements for solar are strong, offshore wind apparently leads whales astray and causes whale death. And so when you look at the 10K statements of renewable energy firms, it's like one statement after another about how nature protection makes it really hard for them to operate, right? And I think that's something that's really important for us to realize, that at some point, if we want to build out renewable energy infrastructure fast, there are going to be conflicts with local nature preservation, right? Just due to the nature of the way that most of the existing renewable energy operates. And I don't think we've kind of figured out, and I'd be kind of interested to hear from Tessa from how you deal with this potentially from an engagement perspective. When you have renewable energy firms that we like because of their climate impact, but yet they might have very adverse impacts on local nature. I think that's a conflict that I'm just not sure has been talked about enough. Lastly, when we then take these firms based on their exposures that I showed you before, we find that also in the stock market, we find indications that this type of biodiversity risk is at least somewhat priced. Though we also run a survey of market participants don't seem to think it's adequately priced. It's hard to know how they come up with that judgment, like what does adequately priced mean? So take that with maybe 2 grains of salt. But it was interesting to us that at least the people who responded to our survey seemed to think it wasn't adequately priced. I think there's also sample selection in terms of who responds to a survey about biodiversity risk. It's probably people who worry about it more than the average market participant. But the market prices show us that it is at least somewhat priced. Okay, so with that, let me stop. I think biodiversity economics and finance is really a new field. There's many unanswered questions. I think there's much, much more research needed here, both on theoretical and empirical fronts. I hope that those of you who are academics in the audience, are interested in this topic and will help us making progress on this, because I think, I think there's a bunch of low-hanging fruits here still. But I also think it's very important that we understand this better than we currently do. And with that, over to Tessa. Thank you.
Thank you so much, Johan. That was just fascinating. And I think you're right. There's so many unanswered questions. And I think that's even shown by the amount of questions we've had from participants today. Just to quickly address your trade-offs point about, often it's the renewable energy companies who face the greatest challenge. I think their challenge really is how they're addressing these risks, and to put them properly in context and what measures they're taking. So all companies have risks they have to address, but it's, are these risks being properly managed and, seen to, as it were. So as I said, maybe a couple of questions on this section, and then I'll maybe give it just a little bit of perspective. So the 2 questions I've picked out are, as a junior researcher, I worry I have to spend a lot of time on my paper on biodiversity before getting to the core finance contribution, in your view, what's a strong hook that makes editors, econ journals really engage with this field, especially if biodiversity outcomes may only become salient after large biodiversity losses? And obviously your FT article is one example. And the second question, what sources are available for individual companies to translate these biodiversity and nature loss risks into specific financial risks?
Yeah, so on the first one, I've always taken the view that good editors and good researchers actually love interdisciplinary work. And again, with interdisciplinary work, I don't mean work that tries to push the frontier in two fields at the same time. That never works, right? And I've been very transparent that, in our work on ecology, the ecology is not frontier in that field, right? It's textbook, second year, third year undergraduate material. But my sense is when I present this to an economics and finance audience, people are really fascinated and interesting, and they really love learning new things, right? And they love coming out and like knowing a bit about niche differentiation and root lengths and extraction of nitrogen, right? Because people are generally, like academics are generally interested in the world. And when one more person comes in and it's just finance, I think what you learn is much less than when someone comes in and also teaches you about ecology and something, and then obviously tries to tie it back into finance. So I would not view it as necessary to I would not view this first bit of a paper that you described, in which you would describe some of the insights from ecology, as a weakness of the paper. If you make it interesting, like people think about, I always think about this, people love reading New Yorker articles. New Yorker articles are sort of long form journalism about a random topic, right? And the best New Yorker article is something where you never knew you wanted to learn about this, and yet the article is so fascinating that by the end you're grateful that you learned about it. I think many editors are like this. They see a million papers on standard asset pricing stuff, and every now and then they see a paper, and I see this myself when I'm a referee or an editor on a paper, and every now and then this is a paper where I'm truly learning something. And I think that's a strength rather than a weakness. So obviously you need the hook in the beginning, as you mentioned, right? You need to promise that you're going to tie this back to finance. You're not going to send a pure ecology paper to a finance journal. But I think if you promise that and you deliver on that, I think it's a stronger paper because it's just generally more interesting. On the second question, what tools are available for firms? I mean, look, there's a lot of commercial data providers out there that are trying to do stuff. I'm not going to, advertise one over another. I also don't have enough insight into the underlying quality of all the different models. My sense is this is where, a lot of the climate risk measurement was maybe 5, maybe 10 years ago, where people were trying hard to do this well. And, here I think we're still in the stage where we have to make conceptual contributions to really figure out what it is that we want to measure. My sense is that, the data on things like water scarcity and water risk, which I think is a subset of nature-related risks, there I think our measurement tools are already a bunch better. On the stuff on things like species losses and biodiversity risk, my sense is I don't know how good any of them can be, because I don't even know at this point, or at least before we did this work, what it is that I would want to measure before I can start actually going out and figuring out, is there any data to actually do this? So I think on stuff like water, I think we're doing relatively better. On some of the other things, I don't know. I don't want to advertise one provider over another, who the frontier is. And you guys probably have spent more time looking at what's out there. I don't know if Tessa has a favorite one or has someone that she works with for that question.
Well, that's refreshingly honest, Johannes. And I think also I probably wouldn't speak to one particular provider over another, except to say I think there are so many in this field and all are tackling it from slightly different directions. So I thought I'd just give a little reflection on what I've heard from a practitioner's point of view and just see explain how we look at it. And I was asked to comment if I agreed or disagreed. I don't think it's really about agreeing or disagreeing. It's more about what we do with this as practitioners. We've got people joining from all over the world. We'll be bringing different experiences of nature loss and its interaction with the economy. And what we've got with this research is something that's applicable to all sorts of ecosystems in a way that's comprehensible, and it gives a common language for companies and investors alike. And for us, engagement on biodiversity starts with understanding where the risk exposures are and encouraging companies to take action to address them. And I really had three main thoughts in response to what we've heard. First, for us, climate engagement now follows a relatively well-trodden path. Nature and biodiversity loss is far more company-specific and sector-specific, so the right questions and expectations vary much more from one business model and supply chain to another. And with climate, we can lean on more standard questions and frameworks that give these common basis for discussions. Second, I'd say that what we found is companies are often less willing to come to the table on biodiversity, and many are at a much earlier stage than they are on climate, which makes progress much more uneven. And of the 4 companies that we've engaged with in more depth over the last couple of years, 3 of them were slow or reluctant to even start having these conversations. And with one, we had to file a shareholder resolution to get them to agree to even meet the investor group. And when they do meet with us, it's clear they've got all the information there, but they're just nervous about having these sort of conversations. And my third point is that's why research like this is so valuable. It connects what's happening in the real world, the physical impacts of nature loss, to what matters in finance and decision making. And it also helps explain the transition side, so how policy and market responses turn these impacts into real requirements for companies. And that makes our conversations with companies sharper and more grounded. Stepping back, I think the bigger point is that analysis like this lets companies, investors get more location specific and more granular and more decision useful. And it helps us prioritize, it helps us ask better questions. For example, Johan, one thing that stood out for me is how closely your sector picture matches what we see in engagement, especially with food and drinks and consumer goods companies. One of our more advanced discussions and dialogues has been with a company in the pharma and biotech field, and your point about fewer options for future medicines has been central to our discussions. So overall, details vary by sector, but the change in approach we're looking for is the same. It's moving from nature is important to what does it mean for the business, what's being done about it, and how do we know it's working? And Johan's framing helps because it links real-world ecology, the ecosystem fragility and the substitutability, to the investor questions of whether those risks are being properly accounted for in decisions. So that's my thoughts on it. It's just fantastic to see so much interaction from the audience, and I think we've still got a little bit of time before we have to move towards wrapping up. So I thought I'd just proffer you a couple more questions.
Sure.
So maybe one from the academic side and maybe one more from the practitioner side. So firstly, what would be good PhD research topics to focus on related to biodiversity in Southeast Asia or Asia regions, looking over a 30 to 50 year time frame? And beyond formal research, how can students contribute to real decision making and action on nature and biodiversity loss? And then the second question would be, as natural capital is more local, should it be treated differently from climate change, especially in a 2-region model?
Yeah, so maybe let me start with the second one, because you're exactly right. I mean, I wrote down, as you point out, a 1-region model. And we're actually one of the papers we're currently working on is extending this to a multi-region model for the exact reasons that you've mentioned, right? Nature is more local than climate. And so you need to take that into account. Also, one interesting thing is the tradability of different ecosystem services varies, right? So timber, I can produce somewhere and ship it halfway around the world. Carbon sequestration as an ecosystem service is by its nature global and thereby tradable, right? Like it doesn't matter where I sequester the carbon. Other things like water filtration are very hard to make tradable. So these have to be provided at a local level. And so we're currently working on, on some model that is trying to create insights into exactly that set of questions, right? Like which of these insights, survive. I mean, I think all of them will survive, but I think they'll be enriched when you introduce multi-sectors. And yes, so that completely agree with that. In terms of like what are interesting questions to work on, I mean, this was one of them, right? Like take a simple one, one region model we have, understand that this is, that there's trade in some ecosystem services that I think a lot of what's been destroying nature in much of Southeast Asia, as you mentioned, has been, producing goods that then get traded to the rest of the world. So how do we think about that? I mean, there's lots of interest. I mean, the Coral Triangle, this one is an example that, we talk about in the in this Asian Development Bank report, as just an example where, this twin crisis multiplier is really hard at work, right? So climate change is destroying the coral reefs. The coral reefs are currently to an extent protecting against climate damages. So you see a lot of these types of interactions. So I could imagine if you're specifically interested in working in that region, then trying to be more quantitative about some of these relationships and trying to put numbers on them. I think that, again, the Coral Triangle is a great place to look for this because it's economic bases for, I think, 200 million people living there, right? So I think if you're going to have a collapse of the local ecosystem there, you're also going to see local economic collapse there that I think could be quite costly. So my sense is that that there is a lot of great opportunities for researchers. I think expanding more about just understanding how to represent the ecology in a way that economists can understand it. I think there's value in that. I think understanding the pricing, the question that came about before in terms of the measurement. I mean, I think part of the challenge, we haven't settled on measurement yet is because we need to make more progress there. I think there's scope for academics on that front. So I think there's really, on all of the dimensions, precisely because it is such a young field on the econ and finance research side, I think there's endless opportunities for young researchers.
Yeah, I agree. And I think it ties quite neatly into how do you hook people into being interested. And I think coral and the coral reefs being one of the first tipping points that we might be reaching is quite a good example of that. So I think we're getting near the close. I have to remember to give Yuxia enough time, but I would just say, Johan, to close, could you give us one sentence you'd like people to remember from today? I'll perhaps give mine first and then allow you to have the last word. So I think my views on it is today's message is nature isn't separate from the economy. It underpins it. And when that foundation becomes fragile, it will increasingly show up in markets.
Yeah, I think that's beautiful. This is a more eloquent version of the exact same thing I would have said. I would just add, just from a research perspective, because I know we've seen a lot of work being done on climate finance. And I think there's a question, broadly speaking, if we should think of this work in nature and biodiversity risks as separate from that in climate. And again, I've increasingly come around to the view that it is separate, that it has a lot of interesting dimensions like this interaction between species or the twin crisis multiplier, but it's obviously not completely separable from it. But where I really think there is the need to view this as a separate research field that PhD students and young faculty can specialize in, and beyond just climate finance. And so I think Tessa, you summed up the content, but I think in terms of people trying to figure out how to make a career, an academic career in that space, I really think we're seeing the emergence of this as a separate field. I think the Review of Finance just published a special issue just on biodiversity finance. I think that's going to be one of many. I think it sends a strong signal. I've written a piece in the Journal of Finance Insights and Perspectives you can find on my website to outline a research agenda in nature and biodiversity finance. Listing sort of 10 questions, 15 questions. I see one of the attendees ask a base of 20 academic articles. I think on the ecosystem side, I would recommend you go to the paper I have, the economics of biodiversity loss. We spent 3 or 4 pages there just describing ecology literature, and you'll find all the relevant papers for that there. I think, I think there's a great opportunity here for people to build research careers. If you think about, the impact that climate finance has had on the academic field, there was a time when I think a third of all conference presentations were in that space. I could see a scenario where nature and biodiversity become similarly important in a way that's distinct from sort of this interest that we have on climate.
Well, thank you so much, Johannes, and also Tessa, for this very thought-provoking conversation. And as I represent accounting scholar here, I will actually also call it to the accounting researchers that this is even a newer field for us, and then we can have a role to play, like for how to account for the biodiversity and how to make it work in terms of like financial impact as well. Yeah, so thank you so much for the conversation. And let me continue to share my slides here. So yeah, I would also like to thank the audience. We see your waves and waves of questions and comments popping into our Q&A function, and then you also share many interesting comments there for us to read afterwards. And also I'd like to thank our organizing committee for your continuous dedication in making this collaboration works. Well, before I conclude today's session, let me just invite you all to join us for our next lecture as well on 10th of March. And this session actually will be in the hybrid format. So if you are in person here in Singapore, I would highly recommend you to come over here to NBS, and then so you can enjoy some refreshments and then network with our speakers and also meet with your fellow participants before the lecture. Of course, if you are overseas, this lecture will be again live streamed via Zoom, so you are more than welcome to join us there. So you can scan the QR code right now to register and stay updated. And I believe this brings our session to a close. And please take a moment while you exit to fill out our feedback survey, and then we'll continuously improve based on your feedback to us. Thank you so much for being here. Thank you, Professor Johannes and Tessa, for contributing to this very interesting and also enlightening discussion. And we look forward to seeing you again next month. Thank you very much.